to have. So we just went over, I guess, do we have any other problems for section 1, or problems 1 through, I think 12, 13?
1.9 is a bit interesting. Or yeah, no, 1.13 is hairy. 1.9 is a bit interesting. We could do that if you wanted to.
Yeah, let's do 1.9.
Do it. So this is the game, right? And all the payoffs are gonna look at that. So V plus is going to be well, it's going to be the minimum of the maximum as per usual, right? And we're minimizing over the rows, columns, sorry.
Yeah.
And we're maximizing over the rows.
And that is given in the equation above for when we defined the V plus.
Yeah, exactly. And like what we'll be minimizing is I minus j, because that's the payoffs in each column as or in each cell as defined up there.
Yeah. Oh well, I won't. I'll just underline.
And so, like if we just look at the in one to begin with, so we know that both I and j can go from 1 to n, as said there. So if we want to maximize the inner expression, so we say that j is constant, or like we don't know what it is. The only thing we can vary is I. So if we want to maximize that, then we want to set I as large as possible, right? And that's going to be n, because that's the largest value that both of them can take. So then we get that this expression will I will actually be n. So it will be we still have to minimize over the columns, but the inner expression will now be n minus j. And again, if we want to minimize this, then we want to set j as large as possible, because then because we subtract it. So then this whole expression will be n minus n. And that's going to be 0, 0. And so the value of the game is going to be 0. And the optimal strategies are going to be that both players play n.
And the I guess you would also to say that, wouldn't you also have to prove that V minus is also 0?
Right. Very true. And I could go over that, but it's basically the same logic. But you're right.
Yeah. For V minus, you just you're doing max. Oh gosh, I want to write it.
We should really find some better way to share math.
Agreed. We could use just a Google Doc and use the math functions for the Google Doc.
Yeah.
It might work a lot better. But yeah, so then you just do, v minus is max min. Which one is the columns? Is it j for max again, or is it each time it's max, it's going to be I?
Exactly.
Yeah. So then this would be n min. Anyway, very similar.
Yeah.
Okay. Cool.
So next section, maybe.
Yeah. I have at least one question that I wanted to. Oh, I highlighted this. Can't remember why. Oh, well, this is kind of answered in subsequent. Or the reason why I highlighted this was because I was just confused as to how exactly this process happened. But I think it follows the same max min kind of formulation we did previously.
Yeah, I mean, more or less, since you want to you want to find a place where the function is where the slope is 0.
Yeah.
Then you take the derivatives with respect to both variables and declare them to be 0 and solve the equation or the system of equations.
Yeah. That makes sense. So let me see. Okay, yeah, cool. I mean, we can. I would have to do that and refresh my calculus stuff.
Yeah, I have realized how much I'm lost in these parts of math. I've been doing too much logic and algebra instead of calculus the last few years, which is nice because I like that better. But this is useful in some ways, so it's nice to freshen.
Yeah, exactly. I mean, I like understanding the concepts, but then I quickly forget the actual, usage or ways to solve things.
Yeah.
So the first one that I pointed out was just 15 because it is relatively straightforward. I think easy to. Well, it actually follows the same or similar formulation that we just did, except it's a bit more complicated. And that's because it's using, technically you might have to, use multiple different equations. So, should I draw?
Sure.
Look forward to this.
I could actually prepare a desktop where we can do the Google Docs thing. You start drawing meanwhile, but
Yeah, that'd be awesome. Okay. So, okay. So generally what we're doing to solve for, so I'm going to solve for plus first, right? So you can just do these two separately and check if they equal each other. So I'm going to do min here, min, max. Oh gosh. And essentially I'm just going to, I don't know if this is proper by any means, which it is not. Oops, it's not x. I'm going to do a little shorthand because I don't want to write everything out. You can see what I'm writing here. I mean, you can see what I'm writing here. Okay, min max f of x, y, and then this is going to be x squared. Actually, it's going to be y squared minus x squared. So to do this, we first want to maximize the value, and we're going to use x. And you know what? I'm not going to actually solve this in a, like, I really should solve this in a more rigorous way. I guess, so in this case, I'm actually going to ask for, well, Jack, you might be, or we want to maximize this, right? And we're able to play with x. And so I can kind of reason it out in my head and say, okay, to maximize the value of this, we're going to want to, oh yeah, so I have to take a derivative of this. Am I right? Am I right on this?
I don't think you have to. You can just say that you set, like, because the function x squared, like it's, like, the function x squared has the lowest point at x equal to 0, right? So the function negative x squared is going to have its highest point at 0. And since you want to maximize, you just set it to 0. So I mean, you could take the derivative, but you would like, since you hopefully know what x squared looks like, you can just reason it out in your head.
Yeah, exactly. That's what I did, is I just said, okay, if it's x squared, and we have the values from -1 to 1, then we're just going to, -1, you plug this in, it's going to be -1. 1, you plug it in, it's going to be -1 again. And so the best you can do is 0, or if you know the graph. However, what is, I mean, I guess the more rigorous way to do it that would work in any case, even if you didn't know what x squared looks like or how it will behave, is if you take the derivative. And so if we were to take the derivative, it would be like, what would we do with y squared? Just
you, like, once you have solved the max part of the equation. Oh, right. So since you're taking the derivative with respect to x, then y is a constant. So y squared disappears completely.
Thank you. That's what I was missing. Yeah. And so then you set it equal to 0, right? No, maybe.
Yeah, exactly.
Yeah. And then you get -2x equals 0. And you solve that out, and it gets x equals 0. Cool.
But then, like, actually, the only thing that you know then is that x equals 0 is like either a maximum or a minimum or a saddle point of x squared. So if you wanted to be really rigorous, you would have to take the second derivative and check whether that's positive or negative. But yeah, since we know what x squared looks like, let's not do that.
You have to take the second derivative?
Yeah, to find out whether it's like what kind of extreme point it is. Because the only thing that the derivative tells you is that the point will, like, the slope is going to be 0, but it could be that it's maxing or that it's minning at that point.
So then I would take a derivative of this or that.
Of negative 2x.
Yeah.
And the derivative of that is -2. And that the second derivative is negative means that it's a maximum point.
Awesome. Oh, yes. Okay. See, once again, I forgot that as well. And I would have done that. Oh, gosh. Yes, that makes sense. So it's negative.
So I actually have a screen with the book and Google Docs ready.
Cool. All right. I'm going to clear and stop sharing.
Okay, apparently that didn't work. If we do this, maybe? No, okay, wait. Oh, no.
What what would it look like if it was, you said it's either maxing or minning, or what was the other one?
Saddle point.
Settle point?
Yeah, as in being like, wait, hold on.
Have to multitask.
Yeah.
Do you have multiple monitors?
Yeah, I do.
That's why this is more difficult, I assume.
Yeah, and also I tried to use the like OS X's like shared full screen thingy, but it didn't. It was I wasn't able to share that.
Mm. Cool.
Yeah. So what I was saying is that a saddle point would be something like this, except for this part, which is nonsensical. But so this in this point, the derivative would be 0, and you like depending on the function that you were taking the derivative of. Like in this case, it was x2, so it doesn't have anything like that. But if it was another function, you could have found such a point instead of a maximum.
And what would the derivative look like? A second derivative look like?
I think it's 0 if it's a saddle point. I mean, that's the only thing that makes sense to me, but I don't remember for sure.
Cool. Okay, cool. Nice little calculus lesson in the middle of our game.
Okay, so where were we? Is this?
Yeah, so I had proved or I had solved at least the V plus, sorry.
Of which one? Right, I should
15.
share the document with you as well. Okay. How do I open the chat while in screen sharing mode?
Is there I think there's ... at the bottom of your screen, something like that. And where Zoom pops up. I mean, you could send it on Tap Hub. I mean, Game Theory Study Group. Just do that.
Yeah, I realized that.
Next time we'll have this sorted out beforehand, and we can have an optimal experience. To all our viewers, I'm just apologizing.
Does it work?
Let me double check. Yes, I'm on. Hallelujah.
Nice. Okay, so you were solving 1.15 or yeah.
Yes. So solving 1.15 essentially was doing the min, max, and I need to do subscript. I don't know. I haven't actually used the math stuff. I'm gonna have to practice.
Skip the subscript. We can see it on the unless you really want to, we can see it in the exercise.
Okay. Yeah. So essentially, did x squared y squared minus x squared. Cool. And we found that this is 0. And so next, what we would have to do to get the other one is, instead of doing min max, we are doing max min. And just for clarification, this is the y and this is x, right? No, this is x and this is y, sorry.
Yeah.
And to do that, we can say that it is max of, and so first we need to minimize y squared minus x squared with regards to y. And so to minimize that, we would technically do the derivative and second derivative. However, in this case, we can just know that y will have to be 0 to be minimized, because anything above or below 0 is going to be squared, so it's going to be like absolute value, and greater than 0. So that means that it instead would be negative x squared, because our y is going to be 0. So I'll guess do 0 minus x squared. And now we have to max that.
Wait. Aren't we, like, we're minimizing on x, so...
Oh, we are minimizing on x.
Yeah.
I think we're minimizing on y, no?
Oh yeah, sorry, I'm confused. Never mind.
Yeah, this is why I always want to like specify the x and y, because it's super annoying. By the way, what is the subscript command? I forget.
It's underscore. Nice.
Ah, sweet. And then so we want to maximize x squared. So the maximum. Maximum of negative x squared, which is is 0. Ta-da! So CED, CDE, I don't know. I don't remember.
QED?
QED. QED. I don't even. Oh yeah, okay. So then we know the formula. The formula goes something like this, where where is it? I think it is v plus equals v minus equals, oh man, I don't remember. Where am I going with this?
I mean, you have already solved A. So, all right, yeah, there's a B. So show that 0, 0 is pure solve.
Does this show that? Sorry, this is A. This was A. And then B.
Yeah, I mean, we know that the value of the game is 0 since they are equal to each other. And we know that the way that we reached the value of the game is going to be a saddle point, and the way we reached the value of the game was by setting both variables to 0. So I think we are done there. I think like you could do it by honestly, I think we're done there. Let's check, I guess. But I think that's it.
Cool. And so that was 1.15.
Yeah, okay. They are, so they're putting, yeah, they're basically checking that the outcome is going to be less than or equal to the outcome if y chooses 0 is always going to, well, sorry, if y chooses 0, the outcome is always going to be less than or equal to the value of the game. And if x chooses 0, then the outcome is always going to be greater than or equal to the value of the game. So they are checking it using the theorem 1.3.8, I think, maybe. No, wait, no, that's with mixed strategies. It's 1.3.8 DC. Yeah, exactly. But yeah, they like basically check. It's a sanity check, I guess. But honestly, I think that in all cases, the information is contained in here, but this is a bit more formal, I guess.
Yeah, that's what I figured. I also highlighted 1.19 as a good one. I didn't actually solve it I don't know if I figured it out myself. I circled it for some reason. Also, do you mind? I'm gonna be right back. I will be back in 2 minutes. I just need to quickly go to the bathroom.
Sure.
I wonder why I circled this. You're just checking it out.
Yeah, I didn't solve it either.
I think I might have just circled it because I was confused.
Yeah, it is a bit confusing. I actually wrote the problem down, but then just drew a line and continued on with the book.
Yeah, that might have been a smart move. Verify that. Yeah, that is a difficult one.
Yeah, I mean,
so much.
let's not do that.
Yeah, seriously.
So next section.
Sounds good. We can. Oh, and also maybe mixed strategies is probably a good like I don't know actually. How long can both of you stay? That's the question.
I gotta go pretty soon. Take my car to the shop.
Okay.
Also, I don't know if you've noticed, but I'm completely useless on this call right now. I'm kind of sick. I can't really think at all. So all of this crazy notation is just like I just don't have the energy for it right now. I'm sorry. I'm such a blind.
No worries.
No worries. Well, thankfully, we've got a video that you can watch every night before you go to sleep.
That'll help. I will review. Where are you posting these, by the way? These videos. The big file.
You can find in the notes for. I'm gonna post some like overview notes for today's thing. And in that markdown file, there's a link to the video. There's also a YouTube channel. So subscribe to Game Theory something on YouTube. But, maybe we go over a quick mixed strategy problem.
Sure.
And then I have, or do you have to jump off like before 10 minutes?
I got 10 more minutes.
10 more minutes. Okay. How fast do you think we can do a mixed strategy problem?
I do it.
Yeah, I think we can do one in 10 minutes.
Okay, sounds good. And Andy, we already talked about the thing that I was thinking of, the Ethereum studies, and kind of making it like a broader, more general thing.
Mm-hmm.
So I'm just going to ask Jack about it. Anyway, so cool.
So you guys going to do a problem right now?
Sure.
I mean, I don't care if you do it down. I was just wondering. Is there anything to stick around for?
We could, like, do you want an easy one or a harder one?
Let's start easy and build up next lecture. And by the way, next week, I'm thinking we just we finish going through the rest of the section in terms of problems, and then go, maybe start chapter 2. But I don't know. I think that we have a lot of problems now, which is really nice, that we can go through.
Yeah, I'm probably gonna start a bit with chapter 2 either way, because I'm finished with chapter 1 now. Maybe I might go back to some of the harder problems now, but we'll see exactly. But I'm fine with not scheduling anything related to chapter 2 for next week.
Yeah, I think I'll probably check out some chapter 2, but I think we have a lot of material. So
we're going to stick with chapter 1 and just kind of keep going through problems and stuff?
Yeah.
That's cool. So I can actually get a chance to do something.
Exactly.
Nice. So we could just start with 1.21. It's pretty easy.
Sounds good.
Should I do my version of the solution?
Yeah.
Wow, I can't do matrices. Okay, but let's do it like this then. Okay, so wait, did I? This. Okay, so for some reason I actually wrote out the matrix. I'm not sure why. But oh, right. Yeah, I know why. Because the problem is a continuation of the things that I did in text.
Yeah.
So I decided to actually come up with those equations by myself instead of looking there. But we can do it the hard way. That's fun. Or well, actually, since we only have 6 minutes, let's do it this way. So we're gonna graph the graphing the lines is gonna be a bit.
Oh, do you want to draw?
Yeah.
There's actually a really cool drawing thing.
Mm-hmm.
Did it pop up on your screen?
No.
Oh no, I have to draw something before I insert drawing and then close. Then you just edit it.
Oh.
Now we have interactive drawing.
Right. Okay, so we're gonna graph the lines. Okay, we could start by doing this. So we're gonna graph the lines y plus 4 times 1 minus y, which is equal to 4 minus 3y. And the second line is going to be, we'll just write it out directly because you have the original over in the PDF. So it's 2 plus y. So this one is going to start at, like, so we're plotting from 0 to 1, right? Like y is going to go from 0 to 1. So when y is 0, this is going to be 4, and when it's 1, it's going to be 1. And this will go from 2 to 3. So let's plot. Okay, so let's say that we have, wow, that's, like that. And down here we have, yeah, sure, why not? Like that. Okay, so now we can't actually see the equations, but you have to trust me. So the first one is going from 4 to 3, right? Or one of them is going from 4 to 1, sorry. So like that. And the other one is going to go from 2 to 4, according to my drawings at least. Nice, thanks. Okay, that was unintended. Like that, basically. So we can see that they intersect like there. And so basically we're finding the optimal strategy for player 2, and player 2 wants to minimize the maximum of the game. So the maximum of the game is going to be this line, and the minimum of that is going to be this point. And yeah, so like this is going to be the optimal value for y, and then the like 1 minus I is going to be 1 minus I. And to find that point, you set those two equal to each other and solve, and then you get that y is equal to a half.
Cool. Awesome. And that, yeah, perfect.
Cool. I gotta get out of here, guys.
Okay, all right. See ya.
See ya.
I'll see you next week, and I'll definitely be a better student then.
It's okay.
Take care.
Take it easy.
Feel better. So, the thing that I was mentioning earlier, was that we have multiple in the DAP Hub channel. We have a bunch of different like study groups, you know, and I was thinking that it might make sense right now. There's, the GitHub organization for the game theory study group is like game theory because it wasn't taken, so I wanted to use it. And then research, but it might make more sense to have just an organization that can house all of the study groups and then, repositories per topic, like major topic. Like for instance, game theory can have subtopics, blah, blah, blah. But like linear logic, for instance, is quite, well, I guess everything's connected, but quite divorced from game theory.
Yeah, I mean, they have connections, but that's because you make the connections, not because they're the same thing.
Yeah. Okay. So then having a repository for also like linear logic and being able to keep track of the stuff there too. And so I was thinking of calling it Ethereum Studies, although I don't really have any opinions on the name, but I don't know what you think, if we should kind of pull the Ethereum like brand / logo into it. I don't know, what kind of, do you have any opinions on naming?
Yeah, I would prefer to keep Ethereum out of it, to be honest. Not because I hate Ethereum, but because I want to be as agnostic as possible.
Yes, I agree with that. So I was also thinking for that reason, like DAP is a little bit more agnostic.
Yeah.
So that does seem to make sense. So do you think so do you think what keyword, the reason why I'm really just optimizing for keyword searches,
right.
like get people who are interested in these topics. And I know a lot of people interested in Ethereum are going to be interested in linear logic and game theory and whatever. Probably though, DAP will be a keyword in the future, if it isn't already now, and have a similar effect as Ethereum. But it's more agnostic. So you think DAP? Are there any other like possible words?
Like crypto economic, but that's a bit more obscure, maybe. I think it's more descriptive, but on the other hand, maybe the goal isn't to be descriptive, but to like keyword optimize, for example.
Yeah.
I don't care that much. I just ask that we keep any specific protocols out of it.
Okay, cool. So then I guess DAP. We'll go with DAP.
Cool.
So I'll just like do DAP studies or something like that, and sounds good. And so I'll rename the organization to that, and appropriately name the game theory research one, and also maybe start a linear logic one.
Yeah, we actually have one for linear logic that I and Dennis have been using.
Cool.
It mostly contains like a README and flashcards for Anki, which has we haven't updated them since December or something. I should really get around to that, but I haven't.
Cool. Well, yeah. So I'll make the organization, and I think you're an owner, so you can always just like create a new repo and then push the one you have there if you want to.
Yeah, sure, absolutely.
Cool. All right.
It's this repo at the moment, so I think we can just move it into the organization, I think.
Yeah. That sounds good.
Great.
All right. Well, time for me to do a lot of game theory and linear logic catch up. My goodness.
Nice.
And my full-time job.
Yeah. Right. Yeah, I don't have a full-time job, so that's pretty nice. I can actually focus on just studying and doing other stuff and actually having free time.
Yeah, that's super, super cool. Oh well. There'll be a time when I'm in the same boat. Anyway.
Yeah, I mean, I will have to get a full-time job at some point. It's just that right now I basically choose to live off of crypto earnings and not having to care about doing boring stuff.
Exactly. I mean, that's a good strategy. I really do think that this is we're slightly deviating from game theory, but this is the right time to be learning about linear logic, game theory, and just being able to understand, like, for instance, I mean, I don't know, maybe I'm going to stop the recording because
Yeah, sure.
anyway, thank you everybody for watching. Bye-bye.